Today we try to learn the basic concept of trigonometric function. As you said, it's a topic of trigonometry. Now what is trigonometry? It actually connects the sides of the triangle along with the angle of the triangle. So it's a relation between the angle and the triangle and the sides of the triangle. That's the basic concept of trigonometry. Now, to learn trigonometry, it actually deals with some properties of right angle triangle, some properties of equilateral triangle, isosceles triangle and all that. Okay. So, first in this basic class, we just discuss the basic definitions of trigonometry, along with we have to give a recall of right angle triangle property, then properties of equilateral triangle. First, we have to learn the basic concept of right angle triangle. Now, for a right angle triangle, what is right angle triangle? It's a triangle with an angle is 90 degree. We all know that, right? So, now we take a right angle triangle. Now, here in this right angle triangle ABC, it is always observed that one angle is 90 degree and one is hypotenuse. In that case, we make it as 90 degree and AB is the altitude, BC is the base and AC is the hypotenuse. That you all learn. Okay. Now, in this right angle triangle, there is another property, which is that's called that Pythagoras theorem, which is very, very important on the point of view of trigonometry. So, what is Pythagoras theorem? It states that hypotenuse square must be equal to the altitude square and the base square. We all learned it, right? So, just recall that formula. So, this is our Pythagoras theorem. This altitude, base and hypotenuse all are the sides, right? Now, our main job to study the trigonometric idea is that for any angle, what is the ratio, or did he find any kind of a relation between the angle and the sides? We will see that. Now, the next topic which must be discussed, that is properties of equilateral triangle. Now, what is equilateral triangle? Now, for the equilateral triangle, all the angles must be 60 degree. So, that is why we draw a triangle ABC, which is obviously a equilateral triangle, and it is obvious that all the angles are 60 degree, as you seen already we drawn properly. Now, we drop a perpendicular from A to BC. So, here we drop a perpendicular from A to BC. So, what happened? If we consider these two triangle, obviously for these two triangle, angle B and angle C are equal, angle D in both sides must be equal. So, therefore, it is a congruent triangle, because for right angle triangle, if the two properties are there, they are congruent. So, based on that congruent properties, BD must be equal to CD. So, what hence? D is the midpoint of BC. Okay. Now, if D is the midpoint of BC, again based on the congruency, these two triangle must be these two triangle must be congruent, and hence these two angles are equal. So, therefore, we can easily prove that these two angles are 30 degree. So, these are the basics property we will use in the concept when we learn trigonometric. Now, go to the next. Now, this property is also true when we deal with isosceles triangle. What is isosceles triangle? That means in that corresponding triangle, BC can be any length, two sides or the other sides must be equal. So, two sides are equal. So, in that case, this property that if we take a midpoint of a base and join them, it will be perpendicular to that, that must work. Okay. Now, here we have to discuss some basic idea of functions. So, what is function basically? Now, function is actually anything that we draw or anything we can do. Suppose you came inside your house, just put a switch and you switch on it, some light is blinking, right? So, it also can be thought of as a function. So, you are getting the input through the switch and some light blinking. So, in the basic way, we have to provide an input and we get some output. That is basic function. But obviously, in mathematics, we deal with some y equal to fx and all that. So, here for any function, we say there is a rule that takes one element from one set or one collection of number from one element to another one. So here take x and y. So with the function fx, the element of this set goes to another set. So that's called function. Now, if that is happen, what is basically happens? Think about, we take an example. Now here it converts all the elements in the set A to another set B, and that's function. Now take an example. In this example here we can think about two function, y equal to x square, and we can think about another function y equal to root of x. Now in those cases just try to find out what is the values, right? Now when we take y equal to x, y can be x, can be any number, that is -3 to 2, all the values, okay. Now when I make fx equal to x square, all the value will be squared up. So therefore it's 149. So my job is done. Now when we do the square root, what happened? We have 1, 2, 3, it is convert to 1, root 2 and root 3. So this is the basics of function. So what that mean? It's meaning that through a function we convert one number to another number. So first case is it converts integer to positive integer, okay, because negative square is positive, that's why all the integer will convert it to a positive integer. For the next case, all the positive integer are converting to a real number. So this is basic function definition. Now we extend this concept for basic idea of trigonometry. Okay, so what is trigonometric function? It's basically, as the beginning of the class we discussed that trigonometry deals with the angle and the sides, length of the sides. So trigonometric function is actually takes the angular value or angle value of any angle of a right angle triangle to some side rate or to some ratio, or angle to some real number. That's called trigonometric function. In general, angle is described by radian measure or degree measure. So as you take your geometry box, open the spectator, you get some degree 0 to 180, 0 to 90 and all that stuff, right? So that's degree we are talking about. And for radian, radian is little higher concept, is actually a measurement, just like unit for the length of a sides is centimeter, someone give you kilometer, someone told you a foot on all that. So there are basically two measures is available for angle. Now the relation between angle in radian measure and the degree measure are actually pi radian is 180 degrees. So just remember this concept, that whenever we have to convert the values in radian to degree, we'll use 180 degree is equal to pi radian, okay. Now take some special beautiful angle, that is 0, 30 degree, 40 degree, 60 degree and 90 degree. So whenever we try to convert it, you will find 0, pi by 6, pi by 4, pi by 3 and pi by 2, just remember. But mostly in class 10 we all solve problem regarding this degree measure. We'll never discuss this radian because that's not required, but you just learned it because in the next year when you are learning the class 11, the first chapter will be regarding this radian and all. So that's why it's mandatory. Okay, now this is the basic function. Now we talk about lot of thing with trigonometric function and all that, but trigonometry is not that difficult. So now we discuss how some scientists or some researcher in long back discovered and find some idea of trigonometry. So to do so, first we take a few different notation of trigonometry, which are sine, cosine, tangent, cosecant, secant and cotangent. Now this is very difficult to remember, right? So the easiest way to remember these values, or we use the notation to represent this trigonometric idea, is sine, cos, tan, cosec, sec and cot. And this are the notation of sine, cosine, tangent and all that, right? Now this all functions are defined on some angular measure. So what is the angle? So we take the angle as theta, then whatever the value we basically call them, or we are asking to find out the values of sine theta, cos theta, tan theta and so on so forth. So this is the basic idea of trigonometric ratio, whatever you said, or trigonometric identity, whatever, trigonometric values, whatever you said. Now, the problem is how we calculate this. This is the notation, just like I define plus, I define product, but how I find out these values? So, it relates with some trigonometric triangle. So, if we draw a triangle, then only we have to able to calculate all those values one by one. Now, we take a line and make an angle. So, whatever the value, it may be 10 degree, 5 degree, 100 degree, I don't know, but some angle. Now, we drop perpendicular from B to C, D to F. So, these angles are 90 degree. So, therefore, we get two triangle ABC and ADE, all are right angle triangle. Now, why I draw it? Because here with respect to the angle A, these two triangle became similar triangle. Now, we try to measure this length. Now, we take this right angle two triangle and try to measure what about the length of AD, what is DE, BC and so on and so forth. Let's see that we can find some beautiful relation, yes or no. Now, take a measure and try to calculate it. Now, you see it is approximately 5 and 3, right. So, therefore, we can take this length AB is 3, AD is 5. Obviously, that is easily observed with the rule, right. Okay. Now, take another rule and try to calculate the length BC. You can easily observe it is approximately equal to 1.7. Just close your eyes in this position and you can easily see that. Okay. Now, what about DE? So, we take another ruler, it is approximately equal to 2.85. Just calculate all those values. Okay, that's it. Now, altitude is obtained, base is obtained. Now, what is left? We left is for hypotenuse. Now, whenever hypotenuse is there, we have to again calculate the hypotenuse. So, in that case, it is 3.4, 5.70. Okay. Now, forget about everything. So, we note down all the values here. That means all the side lengths one by one. Now, whenever it's loaded, whenever we calculate it, let's try to find out. So, first find the ratio of altitude by hypotenuse, altitude by base, base by hypotenuse in some form, right. So, try to calculate it. So, this is base BC by AC, D by AC. Now, see those ratios are constant. If we, so for any angle, if I make it as theta, altitude by hypotenuse for any triangle are constant. Now, if I extend this line and we get another big triangle, then that case also that altitude divided by base is constant. Take the second one, obviously base by hypotenuse. So, in that case also you see it's more or less constant. Okay. Now, take altitude by base, or in that case you said this is constant again, the value is approximately 0.6. So, what we learn? We learn that for any triangle or any right angle triangle, if the angle is constant, the ratios of altitude by hypotenuse, base by hypotenuse, altitude by base always constant. So, what that mean? That can be a properties for a right angle triangle, right. So, for that only we defined three basic idea or three basic concept of trigonometry. So, these ratios are defined as sine A. These basic ratios are generally known as sine A. If this angle, this is cos A and this is tan A. So, these are the ratios, whatever the ratio I get able to receive from the ratio of the sides of a triangle and the angle property or angular value that connects with each other by trigonometry, and we calculate sine A, cos A, tan A and all that stuff. Now, we already discussed that these are the sine A, cos A and tan A. We now wrote down in a appropriate form. Now, we face some difficulties here. So that difficulties we will discuss. Now see, for the angle A, we are able to calculate this is altitude and this is base. Now what happened for the another angle, because altitude and base cannot be interchanged, right? That's not the right way to discuss. So now we will think about the angle C. Now with respect to the angle C, what is my altitude? Obviously AB must be my altitude and BC must be my base. Then there is some issue in definition, right? Because altitude is the height. Height cannot be changed for any figure, right? So that's why we replace the concept of altitude. We called it as opposite. So opposite mean for the angle, what is the opposite side? So that is BC. For C, what is the opposite side? It's AB. So therefore, we also change the definition of sine A, cos A and tan A. Here we just replace opposite altitude by opposite. So what is the formula? For sine A, we have opposite by hypotenuse. For cos A is base by hypotenuse. And for tangent or tan of A or tan of any angle is the altitude by base. So just remember this formula. So this is the basics of trigonometric definition. Okay. Now at the beginning we said there are 6 ratios. Sine, cos, tan already we defined. Now we have to define what is cot, what is cosec, what is sec. Okay. What is that? They are basically the reciprocal of everything. So therefore, if we calculate that, we calculate that sine A, cos A and all that. Now we calculate sine C from this figure. What is sine C? Sine C is obviously say it's opposite by hypotenuse. For C, what is the opposite? Opposite is AB. Hypotenuse definitely AC. So it is AB by AC, BC by AC and BC by AB. You can easily observe carefully to find the value of sine C, cosec C and all that. So this is the way we have to calculate the sine value. So if any side's length is given, take the ratio, find the value of sine A. If sine A is given, just multiply by AC, you calculate BC and so on and so forth. We'll solve some problem at the end. Okay. Now we calculate all the first 3 trigonometric ratios. Now here we calculate opposite by hypotenuse is BC by AC. So there will be the another ratio hypotenuse by base. So if 5 by 7 is constant or some value, 7 by 5 is also constant, right? It's the same thing. So therefore this ratio is known as respectively cosec, sec and cot. So these are the 6 important or only 6 you can talk about the ratio that we have in trigonometry. So there are some ratio and based on that we can solve many problem of trigonometry. So the basic idea of trigonometry is that 6 different ratios and connection between their right angle triangle and the sides. So remember mostly these 3. So if we remember this 3, that sine A is opposite by hypotenuse, cos A is base by hypotenuse and tan A is opposite by base. Using that we can easily able to find cosec, sec and cot just using the concept that cosec is the reciprocal of sine A, sec is the reciprocal of cos A and cot is the reciprocal of tan A and vice versa obviously. So these are the basics of trigonometry definition. Okay. Now here we observe one important thing. We learned that sine A is 1 by cosec A and cosec A is 1 by sine A obviously because they are reciprocal of each other. Now if they are reciprocal of each other obviously their product is 1. So therefore sine into cosec is always 1. Based on the similar logic cos into sec is 1 and tan into cot is always 1. So this is you can say the first kind of identity or relation that you have to remember. Okay. Now mostly these are the properties you have to remember. For any right angle triangle, if you remember this chart, whatever you seeing in the screen now, your job is done. You are easy to remember all those. Just remember that process that sine is opposite by hypotenuse, cos is base by hypotenuse, tan is opposite by base and that's it. Remaining you don't have to remember. So mostly these 3, sine value, cos value and tan value. And the next line, you just remember what is cosec, what is sec and what is cot, because this is not that important, all those definitions. Why? Because if I remember these two, our job is done. Okay. So these are the basics. Just remember this chart. The first chart you have to remember for trigonometry. Okay. Now, for this we can also conclude that if sine theta is opposite by hypotenuse, cos theta is base by hypotenuse. So what is sine theta by cos theta? Okay. In that case, it's obviously opposite by base because the hypotenuse get cancelled. So that's why sine by cos is tan theta. So that's the another property. Sine by cos is tan theta. Okay. Cot theta is cos theta by sine theta. Now, we discuss all those things, right? Now, we use again the definition of angle alpha. So, we calculated everything. We calculated everything with respect to that angle theta with this angle. Now, we try to find out all the ratio of 6 different angles based on this angle alpha. Now, let's do one by one. So, with respect to alpha, what is the opposite side? That is obviously AB. What is the base? That is BC. And hypotenuse is obviously constant. The longest side is the hypotenuse. Now, calculate that using that what is sine alpha opposite by base, that is AB by AC. Cos alpha is obviously BC by AC. Tan alpha is opposite by base. The same thing. Now, similar process we can apply for all those remaining thing. That's nothing a problem. So, only the thing is that whenever alpha or the angle you have to given, you just fix that angle, try to find what is opposite, what is base, and hypotenuse you can easily find the third side obviously. And using that property, that opposite by hypotenuse and all that, you calculate cos, sine and tan. If you calculate all the 6 remaining, you can calculate by reciprocating each other. Okay. So, that is the properties of, or the basic definition of trigonometry. Now, we have to find the values of sine to cot, or the 6 different values for this given problem. Now, how we calculate? Now, see, for the angle theta, we can write this side 6 centimeter is the opposite side, right? This is base, and obviously this is hypotenuse. Now, what is sine theta? Sine theta is opposite by hypotenuse. So, therefore, it's obviously 6 by 10. Cos theta is base by hypotenuse. So, therefore, it's 8 by 10. Now, tan theta, what is tan? Tan is opposite by base. So, 6 by 8. So, main 3 trigonometric identity is already obtained. Now, what have to find? The remaining 3. What are the remaining 3? It's just a reverse of, or the reciprocal of the first 3. So, cosec is 1 by sine, therefore is 10 by 6. Cos theta is the reciprocal of sec theta, or in other form, sec is reciprocal of cos theta. So, therefore, it is 10 by 8. Cot is reciprocal of tan, and hence it's 8 by 6. So, this is the second set of trigonometrical ratio, not that important in the phase of how we calculate. Now, mostly for the first exercises or first lesson, you are asking to solve the similar kind of problem where different sides are given for different right angle triangle. You have to find the sine theta, cos theta, tan theta values. Now, here one thing you will observe. For a right angle triangle, it is obvious that hypotenuse AC is the longest side. Now, when hypotenuse is the longest side, obviously for any values of sine theta, that is opposite by hypotenuse, and base by hypotenuse for cos theta is always that ratio less than 1, right? Because hypotenuse is the bigger value, opposite and base is smaller value. So, some small divided by some bigger value, just like 7 by 8. It's always less than 1. So, therefore, we say that sine theta and cos theta is always less than 1. So, you can say sine theta is less than equal to 1, cos theta is less than equal to 1. Now, obviously, that some side length, right, but side length cannot be negative. So, in that case, we will have it is 0, 0. That means sine theta value and cos theta value always lies inside 0 and 1. Be specifically in a bracket. Okay. So, it lies between 0 and 1. Okay. Now, this is only true. Remember, this is only true when theta is acute. Now, if theta is some other angle, just like theta may be 120 degree, theta may be 180, 160, 340, any angle, right? In that case, this is may or may not be true. But in the class 10 syllabus, we don't have to learn the concept that is how we define sine, cos, tan and all that for an angle which is more than 90 degree. So, we forget about that, but as a recall or as a hint, you just remember for any angle theta, sine theta is always lies between +1 and -1, and similarly for cos theta. This is just to remembering concept, not applicable, and we can't solve the problem regarding sine cos lies between -1 and 1, how it can be. We can't do that because our hand is closed to based on the syllabus. So, when you will be class 11 and all, you can easily learn why it is so. Maybe in the next class on regarding this trigonometry, when we have to calculate the value of trigonometric ratio in some specific angle, just like 0, 30, 45 and so on and so forth. In those cases, we will discuss why sine value and cos value is -1. Hope you understood and you learn the concept of trigonometry, the basic definitions and anything. So, in the next class, we talk about how we find the angles, specific angle and trigonometric ratio, then we discuss the complementary angle, then trigonometric identity and application of trigonometry. So, that's 4 parts or 5 parts are there in your syllabus of trigonometry. Hope you understood the problem. Thank you.